This is section 11.3. We're going to talk about quadratic functions and how to graph them. So, the graph of a quadratic function, which remember those are things that look like f of x equals ax squared plus bx plus c, where a is not 0, is called a parabola. And parabolas look like a bowl or an inverted bowl. Or sometimes I say they look like a smiley face or a frowny face, or they look like a cup or an umbrella. So if a, remember that's the coefficient on the x squared term, if a is greater than 0, then the parabola opens up. And so it looks like this. If a is less than 0, then the parabola opens down. And so it looks like that. The vertex of the parabola is the lowest point on the graph when it opens upwards, so here, and the highest point when it opens downwards, so about right there. So to graph quadratic equations, we first determine whether the parabola opens upward or downward. Then we determine the vertex, find the axis of symmetry, find the y and x-intercepts, if there are any, and if we need to, we find a couple other points to finish our plot. So for example, let's take x squared minus 4. The first thing we're going to do is determine whether it opens up or down. So we look at the a term, and here there is an implied 1 coefficient on the x squared. So since a equals 1, the parabola opens up. Okay, the next thing we do is find the vertex. So the way we find the vertex is first we start by finding the x-coordinate. The x-coordinate of the vertex we find by doing negative b over 2a. And if you'll notice, this negative b over 2a is actually part of the quadratic formula. So in our case, we don't have an x term, so our b is 0. So we have negative 0 over 2 times 1, which is 0. Now that we have the x-coordinate of the vertex, we need to find the y-coordinate. So to find the y-coordinate, we just plug the x-coordinate in. So we have 0 squared minus 4 equals a negative 4. So our vertex is the point 0, negative 4. Now, the axis of symmetry is always a line, I should say a vertical line, and it's of the form x equals, and it's always the x-coordinate of the vertex. So in this case, the axis of symmetry is the vertical line x equals 0. The fourth thing we need to do is find the y-intercept, which means plug 0 in for x and solve for y. So essentially we're finding f of 0, but if you notice we already did that in step 2 because that happened to be the vertex. So that won't always be true, but this time it is. So our y-intercept is the point 0, -4, same as the vertex. Now we need to find the x-intercepts. So for the x-intercepts, remember we take the equation, set it equal to 0, and solve for y. So we have x squared minus 4 equals 0. If we add 4 to both sides, that leaves us with x squared equals 4. And using the square root property, we have x equals plus or minus 2. So we have two x-intercepts, the point 2, 0, and the point -2, 0. So now we can graph these. So to graph, we first plot our vertex, which was the point 0, -4. So that's right here. Then we mark our axis of symmetry, and that's at x equals 0, so we draw, I always use a dashed vertical line there. And it's right on the axis, so I'm drawing it a little bit off the axis so you can see it. Our y-intercept was our vertex, so if we plot that, it's that same point. And our x-intercepts were 2, 0, and -2, 0. And here's where you can see the symmetry of the parabola, because if we look from our axis of symmetry, our x-intercepts are the same distance away from it. So if we wanted to do another point, we could just plug in another value for x. So for another point, let's say I could do f of 3. And I would get 3 squared minus 4, which is 9 minus 4, or 5. So I would have the point 3, 5. So if I go put that one on my graph, I'm not going to change colors back, but 3, 5 is right here. And because of the symmetry, I know that if I go the same distance on the other side, so to -3 of that axis of symmetry, I can put another point right there. So I know the parabola opens up. All I have to do now is connect the dots. Which I didn't do super well, but there you have it. As for the domain and range, remember the domain is all possible x values, and if you notice there are arrows here, so that means that this keeps getting wider and wider forever. So our domain is -infinity to +infinity, if we write it in interval notation. Our range, you notice it goes up forever, but it doesn't go any lower than -4. The range is all the possible y values. So our range goes from -4, and we use the square bracket because -4 is included, to +infinity. And remember, whenever we use infinity, we use parentheses. Now, there's another example on the next page, and I want you to pause the video and try to do it on your own before you look at my solution. Okay, so hopefully you have attempted to do this problem on your own. The first thing we need to do is decide whether or not the parabola opens up or down. So, in this case, A is a -1. How did I get that? Well, if you notice, the x squared term is written second here, so we really need to rewrite this with our x squared term first. So that gives us a -x squared plus 2x plus 3, and now it's easy to see that our a is a -1. So this one opens down. Okay, the second thing we need to do is find the vertex. Remember, the x-coordinate of the vertex is -b over 2a. In this case, b is a +2, so we have -2 over 2 times a -1, which gives us -2 over a -2, which is a +1. Okay, we're going to plug in our x-coordinate now and get out our y-coordinate. So, f of 1 is -1 squared plus 2 times 1 plus 3, which gives us -1 plus 2 plus 3, which is a +4. So our vertex is at 1, 4. Our axis of symmetry, remember, is always the line x equals whatever the x-coordinate of the vertex is. So in this case, it is 1. Now let's find our y-intercept. To find the y-intercept, we plug 0 in for x. So, f of 0 is -0 squared plus 2 times 0 plus 3. 0 squared is 0. The negative doesn't matter. 2 times 0 is 0. And then we have a plus 3, which is 3. So our y-intercept is the point 0, 3. For x-intercepts, we set y equal to 0, meaning we take the equation, set it equal to 0, and solve for x. Now, I can't factor with a negative x. I mean, you can, but it's hard. So the easiest thing to do is multiply both sides of the equation by a -1, just to make it go, that leading negative disappear. So when we do that, a -1 times a -x squared gives us a positive x squared, minus 2x, and then minus 3. We're distributing. And 0 times a -1 still gives us 0. Now, this is an easy case to factor. Or you can use the quadratic formula, whatever makes you happier. I'm going to factor. So that factors into x minus 3 times x plus 1. And so we know x minus 3 equals 0, or x plus 1 equals 0. So x equals 3 by adding 3 to both sides, or x equals negative 1 by subtracting 1 from both sides. Okay, so let's graph what we have so far. We know our vertex is at 1, 4. We know the axis of symmetry is a vertical line that passes through that point. So here's our axis of symmetry. Okay, we also know our y-intercept is at 0, 3. And remember, because of symmetry, we know that we also have a point at 2, 3. And we have our two x-intercepts, negative 1, 0, and 3, 0. Since we know this one opens down, all that's left to do is draw our parabola and pretend we actually got through the points. Okay? The domain, again, since this just keeps getting wider and wider, the further gets wider and wider the further we go, we know that every possible x value, which is the domain, gives us negative infinity to positive infinity. For the range, that's all the possible y values. Well, it goes down forever, but it never goes higher than a positive 4. So our range is negative infinity to a positive 4, and that has a square bracket on that side of the interval because 4 is included.